Look up. That's not the sun. Not really. It's a photo. An old one. 8 minutes old. You're staring at the past. Every single time. The light hitting your eye right now left the sun's surface before you looked up, crossed 150 million kilometers of empty vacuum, and only just arrived. If the sun vanished this second, you would not know. You would keep seeing it, warm and bright and perfectly normal, for 8 more minutes. Here is the number. The sun sits about 149.6 million kilometers away. Light moves at 299,792 kilometers every second. Nothing moves faster. Nothing is allowed to. Divide one by the other and you get 8 minutes and 20 seconds. That is not a metaphor. That is a division problem. And that number moves. Your orbit is not a circle. It is a slightly squashed oval. In January, you sit closer, and sunlight arrives in about 8 minutes and 11 seconds. In July, you sit further out, and it takes about 8 minutes and 28 seconds. 17 seconds of difference, just from the shape of your path. So the famous 8 minutes is a rounding. The real answer breathes across the year. Now here is the part that should bother you. That 8-minute trip across empty space is the fastest, easiest leg of the entire journey. The hard part happened before. Go down into the sun, past the surface, past the churning layer beneath it, deep into the core, where the pressure is crushing and the temperature runs to 15 million degrees. That is where the energy starts. Hydrogen nuclei slam together and fuse into helium. The helium weighs slightly less than the parts that made it. That missing mass leaves as energy. Not much per reaction, but it happens constantly, everywhere in the core, all at once. And that energy now has to get out. It cannot just fly out. The sun is not empty. It is packed with plasma, wall to wall. So the energy takes a step, hits a particle, gets absorbed, gets spat back out in a random direction, hits another, absorbed, re-emitted, random direction again. Not a beam, a stagger. Physicists call it a random walk. Imagine walking across a room, but every step points somewhere new, chosen at random. You will cross that room eventually. It will just take you a very, very long time. The sun's radiative zone is not a room. It is hundreds of thousands of kilometers of dense plasma, and every step is microscopic. How long does that take? The honest answer is a range. Estimates run from tens of thousands of years to well over 100,000, depending on the model of the interior. Nobody can hand you a single clean number because nobody can watch it happen. But hold the small end of that range for a second. Tens of thousands of years. The energy warming your face today began its escape while the last ice age was still gripping the planet. It has been fighting its way outward, one random step at a time, ever since. Then it reaches the surface. And the last 150 million kilometers across pure empty vacuum takes 8 minutes. The vacuum is the easy part. The sun itself was the maze. Now push outward. Sunlight reaches Mercury in about 3 minutes. It reaches Mars in around 13. Jupiter waits roughly 43 minutes for the same light that took 8 to find you. Saturn, about an hour and 20. Neptune, more than 4 hours. Same light, same speed, just further to fall. And that is still inside your own solar system. Step outside it. Proxima Centauri is the closest star to your sun, 4.2 light-years away. That phrase is not poetry. It is a measurement. The light from that star, arriving tonight, left 4 years and 2 months ago. Look at it, and you are looking at a star as it was before your last birthday, twice over. Push further. The bright stars scattered across your night sky sit hundreds, sometimes thousands of light years out. That light left before anyone alive was born. The night sky is not a picture of the universe. It is a stack of snapshots, every one a different age, all arriving at your eye on the same night. You are not seeing space. You are seeing time. So why does the delay exist at all? Because light has a speed limit, and information cannot outrun it. The sun cannot tell you it is there any faster than light can carry the message. Neither can anything else. which means the delay is not a flaw in your eyes. It is not a limit of your telescope. It is built into the structure of the universe. And here is the uncomfortable part. It does not only apply to stars. Look at your hand. Light bounced off your skin, traveled to your eye, and hit your retina. That took time. Not much. Around a nanosecond for every 30 centimeters. Then your retina had to convert it into a signal. Then that signal had to travel up your optic nerve. Then your brain had to assemble it into an image. Add it up, and the hand you are looking at is a few tens of milliseconds old. Your screen, your room, the face of the person across from you, all old, all arriving late. You have never once seen the present moment. Not for a single instant of your life. Every image you have ever had was a report from the past, delivered by light, always running behind. The sun does not break that rule. It just makes the delay big enough to notice. So look up again. That warmth on your face crawled out of a nuclear furnace over tens of thousands of years, staggering blind through plasma, step after random step. Then it crossed the emptiness in 8 minutes and 20 seconds. And it landed on you. Right on time. 8 minutes late.